Assalamualaikum and hello to everyone. Today our group will present a project entitled Anatomy of an Exploit, SQL Injection and Remediation. This project focuses on one of the most common web application vulnerabilities, which is SQL injection. We demonstrate how the vulnerability can be exploited, analyze its impact on security, and then show how it can be remediated using secure coding practices. In addition, the entire experiment is implemented in a containerized dual environment lab using Docker, allowing us to compare both vulnerable and secure systems side by side. So this slide shows the complete life cycle of our project. First, we build a realistic SQL injection vulnerability in a PHP and MySQL environment based on the OWASP top 10 injection category. Next, we exploit the system by performing authentication bypass attacks and analyzing the impact on confidentiality, integrity, and availability, also known as the CIA triad. After identifying the vulnerability, we remediate the code by replacing insecure SQL query construction with prepared statement and parameterized queries. And finally, we package the entire project using Docker Compose, making the environment easy to deploy and reproduce with a single command. This slide illustrates the architecture of our dual mirror lab. The lab consists of two identical web applications with a different backend implementation. On the left is the vulnerable environment where the application use direct SQL concatenation. This is secure coding practice allow attackers and to inject malicious SQL commands into the query. On the right side is the secure environment where prepared statement and parameterized queries are implemented. This prevent user input from being interpreted as executable SQL code. Both environments use MySQL databases and are managed through Docker Compose, allowing us to compare vulnerable and secure implementation under the same condition. So this slide explains how the SQL injection vulnerability occurs. The target is the login page running on port 8081. Users enter a username and password through the login form. The flaw exists because the application accepts user input without a proper validation or sanitization. This is categorized by OWASP as an injection vulnerability. The backend then directly concatenates the user input into an SQL query. As a result, the database cannot distinguish between legitimate data and malicious SQL command. This allows attackers to manipulate the query logic, potentially bypass authentication and gain unauthorized access to the system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Zuhimi, and today I will explain about resetting the authentication bypass payload. Okay, let's look at how the attack code works. The attackers use the text or one equal to one. The first quote sign trick the system into closing the expected text early. Then adding or one equal to one creates a rule that is always true. Finally, the two dashes act as a command telling the database to ignore everything the command come text, including the password check. This slide shows how the attack treats the database. First, the attacker types the trick code into the username box. Next, the system code wrongly meets the text directly into the database command. When the database reads this, it gets confused and completely skip checking the password because of the command dashes. Because 1 equal to 1 is always true, the database just let the attacker in as the first user it sees. When we let hackers run their own commands, it breaks all three parts of basic security, known as CIA triad. For confidentiality, hackers can steal private information like emails and passwords. For integrity, the data is no longer safe because hackers can change or fake student records. For availability, bad actors can delete whole tables or break the system so normal user cannot log in at all. To stop this attack, we use something called prepare statement, which keeps the system code the user text completely separate. First, the app sends an empty template of the command to the database with a question marks. Then the user text is sent separately just to fill in the blank. The most important part is that the database know this is only the text. Even if the text look like dangerous code, the database will not run.
So next is about code transformation, port 8081 versus port 8082. These slides compares the vulnerable and secure login systems. On the left, port 8081 use SQL query concatenation, where user input is directly added into the SQL statement. This allows attackers to inject malicious SQL code and bypass the authentication. So on the right, port 082 use prepared statements with parameter binding. Users input user input is treated as data instead of executable SQL commands, preventing SQL injection attacks. This simple change significantly improves the security of the application. So for the next slides, it's about layering secondary defense for comprehensive security. Next, besides prepared statements, we added several additional security measures. These include input sanitization to remove unwanted characters, output encoding with HTML special chars to prevent cross-site scripting, secure session management by regenerating the session ID after login, and we create password hashing to protect user password in the database. Together, these layers provide stronger protection against multiple web security threats. So next, the secure reality payload payload neutralize. Here we test the same SQL injection payload and on the secure application. Since prepared statements are used, the payload is treated as normal text instead of SQL code. The database searches for the exact input as a username, finds no match, and the login fails with invalid credential message. This confirms that the SQL injection attack has been successfully blocked. So, to ensure both environments run consistently, we deployed the project using Docker Compose. Four containers were created, two for the vulnerable system and two for the secure system, each with its own application and database. The database are automatically initialized with the vulnerable version storing plain text, password, and the secure version using bcrypt hashing. This setup allows us to compare both environments fairly while keeping them isolated from each other.
For single command reproducibility for grading, we will use Docker Compose build, and for the vulnerable portal will be localhost 8081. For the secure portal will be HTTP localhost 8082. This is our testing credential, which is admin with the password admin123, AMA with the password AMA123, and for the last one is Faris with the password Faris123. Security is a systemic requirement, not a localized patch. For the code level, we will eliminating a syntax confusion via prepare statement. For the database level, cryptographically securing stored credential via bcrypt to minimize breach impact. And for the last one is environment level, utilizing container isolation, Docker, to ensure safe, reproducible deployment. For the insight, the most effective defense against OWSP vulnerability is defense in depth. A single vulnerability can compromise an entire system, require mitigation at the code, database, and infrastructure level simultaneously. This is our academic reference and source material, which is Startup D and Pinto 2011, Zalewski M 2012, The Tangle Web, A Guide to Securing Modern Web Application, and the last one, OWSP Foundation 2021, Injection OWASP Top 10. That's all from our team. Thank you. A vulnerable version of our student portal web application that contains intentional security flaw. Let me begin by showing the vulnerable application. This is our portal login page. The application allows students to log in, view announcements, and search for other students in the directory. Let me demonstrate normal functionality first. I'm logged in as a regular student Amar with the password Amar123. As you can see, the dashboard loads successfully, showing university announcement. The interface is clean and professional, built with modern web technologies. I will navigate to the student directory and search for student ID STU 2024-001. The system correctly returned the information for Amar Danish. As you can see, this is how the application is designed to work under normal condition. Now let me demonstrate the first SQL injection vulnerability, which is authentication bypass. In a secure system, you will need a valid credential to log in. However, due to improper input validation in our vulnerable code, I can bypass the authentication entirely. Let me demonstrate it. I will log in as a admin. And I will put anything for the password. I just write anything. As you can see, any random text in the password field I have inserted. Watch what happens when I click login. I have now logged in as the administrator without knowing the password. Here is the technical explanation. The vulnerable PHP code directly concatenates user input into the SQL query without any sanitization. The query becomes select from user, where username, admin, and password becomes anything. The two dashes followed by a space is a SQL command. It tells the database to ignore everything after it, including the password verification. This completely bypasses the authentication mechanism. This is a critical broken authentication vulnerability that could allow attackers to gain unauthorized administrative access. Now for the most severe vulnerability, data extraction via union-based SQL injection. The student directory feature is supposed to search for student by their student ID. However, the search parameter is vulnerable to SQL injection. Let me demonstrate it. I'm injecting this payload union select username, password, email, role from user. Look at the result. The table is displaying data from the entire users table. But here the critical security breach. Look closely at the full name column. It's showing plain text password, which is admin123, ama123, and faris123. Why does this happen? The original SQL query expects to return student information. Our union attack pin a second query that extracts the username, password, email, and role from the users table. The application is blindly output whatever the database return without validating what data is actually being displayed. This is a catastrophic breach of confidentiality. An attacker can now extract all user credentials, access sensitive personal information like student email, identify user role in the system. In a real-world scenario, this could lead to identity theft, credential stuffing attacks, and complete system compromise. For this demonstration, I have used manual exploitation via the web browser to show the mechanics clearly. SQL map for automated vulnerability detection and data extraction. Burp Suite to intercept and modify HTTP requests. These are industrial standard penetration testing tool used by security professionals worldwide.